Hi students, today we will discuss about the important pins that are related to 8086 pin diagram. In the last class, I told about how to remember easily the pin diagram. In the last class I explained. In this class we will explain some of the pins that are related to 8086 pin diagram, right? So far what we discussed is, we discussed about AD0 to AD15, we discussed AD0 to AD15, and we discussed about what is that A16 and A17 and A18 and A19, right? So these are the AD0 to AD15 is available in multiplexed pin, that is both address. The addresses are from A0 to A15 and data is from D0 to D15. This is the data bus and this is called as multiplexed pin. And remaining are what, A16 to A17 and A18 and A9. These are also address bus. And also I explained this ground, and here ground 1 and 20 pins are ground, and 40 pin is power supply VCC. How much power we are giving? Plus 5 volts. Remember, plus 5 volts power we are giving. And reset, what is the use of reset? By clicking the reset, all the registers are set to 0. Right? So 8086 microprocessor is how much data bus? Number of times I am telling how much data bus? 20 bit address bus and 16 bit data bus. Now coming to the clock. So clock pin number is how much? 19. The pin number of clock is how much? 19. So clock means it provides the timing signal to the processor for the operation. So first clock cycle address will be enabled and the later it goes for another one, right? Clock means what? It provides the timing signal, right? So I already explained in 8086 microprocessor is available at 3 different clock frequencies. That is, the clock frequencies available is 5 megahertz, 8 megahertz and 10 megahertz. 10 megahertz, right? So that is pin number 19. Now coming to next pin. The next pin, that is NMI. That means non-maskable interrupt. What is the pin number? Non-maskable interrupt. Pin number is 17. Pin number is how much? 17. Pin number is 17. So non-maskable interrupt, that means, so when this interrupt comes, the processor must execute this first interrupt, this non-maskable. We cannot ignore this interrupt. So when the processor is, suppose this is the processor is doing some operation, right? When this NMI pin number 17 is activated, then the processor must do this first interrupt, first execute this interrupt. That is called non-maskable. We cannot ignore this interrupt. Whenever the interrupt is NMI is high, first this microprocessor first execute this NMI interrupt. First microprocessor will execute this NMI interrupt, right? Next one is, if you see here, and next INTR pin number is how much? Interrupt request. INTR means interrupt request. What is the use of interrupt request? So suppose any other devices or any other peripheral devices want to communicate with microprocessor. Suppose some IO devices are there. So this is 8086 microprocessor. This is want to communicate this. Then this interrupt request should be you have to do. That means I want to communicate with microprocessor with you, so please access my request. Then this is putting some request to the microprocessor. Then microprocessor can know that okay, some other devices want to communicate with me. Then the microprocessor will execute that interrupt. Dear students, please pay attention. This is very important, right? So that is now coming to the address and status bus. This is called what? Multiplexed bus. Multiplexed pins. So multiplexed pins, what are those? from pin number 35 to 38. Pin number 35 to 38. What are the pins? 35, 38. 38 is A16, A17, A18, A19 slash S3, S4, S5, S6, S3, S4, S5, S6. So these are available multiplexer pins. During the first clock cycle, right, when we are giving the pins, during the first clock cycle, what will be activated? The address will be activated. During the first clock cycle, address will be available. First clock cycle, right? So they suppose let us consider four different clock cycles. So in this first address, in the first clock cycle, this is T1 and let us T2 and it is T3. In the first clock cycle, what happened? Address will be available. So later it carries status. From this it carries the status signal. Later it carries the status signal. What are the status? S3, S4, S5, S6. So first it carries, that means during the first clock cycle we will get the complete address, that means from A0 to A19. So A0 to A19 during the first clock cycle we will get the complete address in A0 to A0 in the first clock cycle. Whereas in the next clock cycle, what we will get? In the next clock cycle we will get the status. So after the next clock cycle, the data and status will be activated. Please try to remember. What I am telling is, in the first clock cycle, what will be activated? In the first clock cycle, the address will be activated. The address will be activated. In the next clock cycle, status and data is activated. Status and data will be activated, right? So that is. Now coming to pin number 34. Pin number 34 is what? Bus high enable. Remember, pin number 34, BHE, that means bus high enable. Bus high enable. Right? It is used to indicate the data, transfer of data using data bus. That is used to indicate transfer of the data using data bus, that is D8 to D15. Remember, D8 to D15. This signal is low during the first clock cycle, thereafter it is activate. So it is used to indicate the transfer of data using data bus, that is higher order 8-bit data, higher order 8-bit data activated. When the signal is low, this is low during the first half cycle and thereafter it is activated, that is bus high enable. It is used to indicate transfer of data using data bus. Now coming to the next pin. What is pin number 32? Now we will go for pin number 32. What is the pin number 32? RD bar. RD bar. What is the pin number? Pin number is 32. So it is used to indicate read operation. It is used to indicate perform read operation. When the bar is there, what I told in the last class, I told when any signal is having above its bar is there, that means that is which signal? Active low. That is called as active low signal. Active low signal. Right? That is the RD bar, used to indicate the read signal. Right? And next one. What is the next one? Mn by mx bar. Mn by mx bar. What I already told, pin number 33. Pin number 33, what I told? Whether the 8086 microprocessor is operated on two modes. 8086 microprocessor is operated on how many modes? Two modes, minimum mode and maximum mode. Minimum mode and maximum mode. So when mn by mx bar is there, that means it is active low. This is high, active high. Mn is active high, right? When it is high, that mn by mx bar is high, that means it is operated on which mode? Which is mn by mn mx bar. High indicates what? Minimum mode. High indicates minimum mode. Remember, this is very minimum mode means what? It is a processor is operated on single processor. Processor is operated on single processor. So now when it is low means what? The processor, it means operated on maximum mode. Processor is operated on maximum mode. What is meant by maximum mode? Multiprocessor. That means we are using two or more processor. Two or more processor. Multiprocessor means what? Two or more processors. Right? Next test 23, pin number 23. See, pin number 23 is test. Remember, this is also active. What is this? Bar is there. Then it is also what I can call it is active low. That is also active low signal. Active low signal. Active low signal. Dear students, please pay attention. This is very important. Active low signal. Now, what is meant by active test signal? The signal is like wait state. Remember, the signal is like wait state. That means it tells test, T-E-S-T, test bar. What is the pin number? Pin number 23. And this is what? Active low signal. Active low signal. Signal is like wait state. It represents a wait state. That means when the signal is high, then the processor has to wait for ideal state. Processor is wait for which state? Ideal state. So low means execution continues in the normal way. Execution continues in normal way. High means when this test signal is high, that means processor has to wait for ideal state. When it is slow, execute for continuous to the normal execution. When we are communicating with the number of devices, suppose when we are communicating with the peripheral devices, this test signal is used. So when this signal is high, that means processor has to wait for some time, wait for ideal state. Then it is low, means it executes in the normal state. It is executes in the normal state. Right? Next one is then we will go for minimum mode pins and maximum mode pins. See, these all pins are completed. VSS we completed, in MI interior clock, VSS ground, these all completed. RD bar is also completed, ready. A reset test, we completed these signals. Right? Now in the next class we will discuss about minimum mode pins and maximum mode pins. In the next class we will discuss about minimum mode pins and maximum mode pins. Until then, thank you.